Python help to the operator, you will find that every operator has appearance parameters which are node X value in Network Editor. Yeah? So you can change color, you can change width of the node, position, so everything basically you can do with operator in here. All of these things can be scripted, because everything you do with this node saved somewhere. That means you can change this data. Yeah. Basically, I would say possible is almost everything. What is not possible is also possible, but more complicated. So the question is not if it's possible or not, but how it's possible. I would change the frame to that question. And we have a circle. Then we can convert this circle to the SOP2, to the table. So we have the table containing all point data. Then we can create the circle top, and we can generate the same amount of circles like the rows in the table using Replicator. So we need template dot, and we need master operator. Then we disable the layout option, so the replicator doesn't position them. Okay, first we position that using onReplicate to make the basic position of the nodes, and then if table changes, we can make a change for their position interactively. So that sounds somehow logical. So we can do it, and here there is a small trick in this function. If you look more detailed, you have here a very nice template on replicate. We have comp, the replicator component, all ops are all list of replicants, new ops, the replicants created last time evaluating this function. That happens if you change the amount of, for example, it was 10 rows, now we have 12 rows, so it will create 2 additional replicants. And then you have a loop for C in new ops. That means all code here will be only applied for the new replicants. But we need to apply it for the all replicants. So we should edit that template by changing new ops to all ops. Then C became a reference to the replicant, so it will be every of these items. And then we use the node X and node Y for setting. So we set it like, okay, first we need to get from the replicant its number. And for that, every TouchDesigner operator has the variable called digits. Let me find it. Digits that will return the digit in the name, on the end of the name. Because if we have several operators, TouchDesigner cannot have several operators with the same name. It will always add the digit on the end. That's how we can iterate through operators. So if we generate the items from the replicator, it will produce the digits from 0 to until the end. So then in order to access the data from that table, we need that digit. So first we make a num variable and write C digits. Then we need to add +1 because we have numbering from 1 here. Or we use the index as access to the row number. It's also possible. Okay, then we ask X, it will be, we have template table, so we even don't need to write op a name of that. We just use template, square parentheses, then in order to access the row, in order to access the cell, we first need to write a row, either number or name, and then column. So we have row number, which is num. Then column name will be P0. So we can just copy it from here. Then we copy that and replace Y and 1. And let's multiply it by 100. Because the network editor is about big digits. So let's multiply it by 100. And we should be sure, basically, that way we're referencing the cell, even not string. We're referencing the cell object. So we need to convert it to integer to be able to multiply it by 100. Because if we multiply cell by 100, we just make error. If we multiply string by 100, we will have the string copied 100 times. That's a small trick. That's not that obvious. So we need to convert that directly to the integer. Even not to integer, let's convert it to float, because otherwise we will miss the data after the dot. So let's make float and multiply by 100. And now we just set C node X is equal to X, and C node Y is equal to Y. And in order to see the result, we should click Recreate all operators. Okay, we have some error. Line 20. Yeah, let's just check. We have items starting from, we have items starting from 1. Okay, that is a problem. Because we have here ignore first row, in the replicator because replicator supposed that the first row is just a names, not a data. And we were adding 1. So that means the last item we exceed the size of the table. So we don't need to add 1 here because digits are already starting from 1. And now we just recreate all operators. We have no mistakes and all things are ordered properly. So basically that shows we can even make it bigger than 100. Let's make 1000. So, okay, 1000 is too much. Let's make 300. Okay. So let's say the project, smoke a cigarette, and then we do the dynamic animation for that. Then what I want to rotate a circle and make all the things also rotating. Then we can control the radius of the circle by the sound. Yeah? And make them react. I think it's actually almost senseless, but it's a good example for going through all the logic. Actually, if you remember, one of the first world-known projects about done with TouchDesigner was Alva Note performance called UniDisplay, which was done in TouchDesigner, and there they were using TouchDesigner interface as a performance tool with gnomes. I will try to find the pictures. And to that times it was no Python yet in TouchDesigner, so they programmed some tools in T-script to zoom in and zoom out in TouchDesigner network view, because it was scheduled through the performance time. So he was performing like that. It's a genius idea to use TouchDesigner interface, and all the zooms were programmed in TouchDesigner itself. It was not Karsten Nikolai zooming in these things, it was programmed. So basically, it's also not completely silly idea to animate viewport. Yeah, it's also possible. Also, like if you remember, I told you can evaluate script if you delete the operator. You can make not deletable operator. Okay, so then I will put the null in between the sop to dot, and I will insert first the transform here, so I can at least make rotation around z-axis, and then I will make ups time dot seconds, maybe multiplied by 10, to make it a bit faster. And now I go to create the .execute. And let's look more detailed into .execute. So we have here on table change, on row change, on column change, on cell change. I think makes sense to work with cells directly. So basically we can see that everything is static, only the values of these two columns are changing. So let's now we need to understand what kind of data we have in changing cells. So we have here again 3 variables, dot and cells and previews. So let's just debug the cells. And in textport and I need to enable this function. So that outputs all values of cells. Let's look to the documentation what we can know about the cells, because now it's became a bit more complicated. We need to know to which columns these cells belongs and to which row. So that we can find in that documentation, just go down until we find a cell written with hyperlink. So we click here, and we see here row, col, and val. So using row we can know the number of operator we're dealing with, and col we can ask if col is 1, then it's X transformation, then col number is 2, then it's Y transformation. So we write it a bit differently. So we make so let's make first two variables, X is equal to 0.0 and Y is equal to 0.0 to make it float. Then if cells dot col is equal to 1, then we're dealing with X. Then we should make X is equal. Okay, let's just debug the cell to see what we get. Okay. That's the list, so we should go differently. We should go for each for cell in cells. That way we look through cells because we receive a list of cells. So then we debug cell. Debug cell. So now it works correctly. So now we can check if cell row is cell col is equal to 1. Then we okay, now we don't need to write it here, because otherwise we will always overwrite the same variables. So we declare it here inside of loop. Then if call 1, then x is equal cell val as float. And let's debug. Debug x working. Cool. Then num is equal cell row it will start with 1. So then we can, let's just convert it to string, because we need strings, yeah. And okay, let's make op. Let's make let's use the same name. C is op item plus this number. Let's debug the result. Looks good. So then we set C node x is equal to x multiplied by 300. Then we copy this block and replace for y is 2. Then actually we could optimize that calculation. We just need to make once, because it will not change. So, and we calculate only y, and write it here y and y. Then actually we can do a lot of funny stuff, yeah, with that. So let's just make the sound audio file in. Then we can select only one channel. Then we can make the spectrum, and in spectrum we have here 40 points, so we will make the 40 samples. Then I will set the p-scale value. Let me think. I need to convert that to SOP to chop. That is original point positions. Then I copy and I convert normal. Normal, we can use the point position also. So then we just need to resample that to new red same index range. Then 40. That is the minimum, so we need to stretch that to stretch, and we start from 0 until 39 samples. So we make absolute samples 0, 39. Then we multiply point position combine chop multiply. Then we should add that to original point position. Again math and combine channels, combine chops, add. And now we can use the chop to SOP to make the opposite conversion. And then we can do the audio device out. So not bad.